Hello everyone, this is Mr. Ege, and this time I'm going to demonstrate in this video how to launch already designed rocket. And in the last video we assigned mass effects properties to the solid model of the rocket so that it gained its own mass, and I demonstrated that it fell down a few times on the ground. So today I'm going to demonstrate how to launch the rocket to the certain height. And for that, we have to give the rocket an initial speed, okay, to demonstrate that that initial speed is good enough, strong enough, large enough to have the rocket reach to the maximum elevation, which is 35 kilometers up in the air. And to demonstrate that, in the earlier video, I added a measuring tape about 35,000 meters high next to the rocket. And in the meantime, between this video and the last video, I find time to add some additional fuel storages to the rocket. Hey, maybe the pilots, astronauts can change their mind and go to Mars instead of the orbit after the orbit elevation. So we added some extra fuel storages and extra fins on the body. Okay, so I modified the design a little bit, adding additional fuel storage and so on, but basically it's the same rocket. And I just want to demonstrate a few more things before we launch it, okay? And one of the advantages of having this videos is that you can play it back and forth if you miss something, anything, or you don't have to remember or memorize every single frame of the video. You could always take it back and watch something that you might have missed. So this is an ideal learning environment, I think, from that point of view. So this is the screen, and you're looking at the body of the rocket, and this is a little bit of higher than ground, okay? And on the left side, you will see a Scene Explorer menu. It's not that important, but I'm just going to demonstrate to you that it's made out of the components of the boxes, capsules, gravity, plane, and the tape, the measuring tape, 35,000 meters high, and the target tape. So all of this is actually to demonstrate you what is existing. You can turn off these items by just clicking on the icon on the left. It turn it off and turn it on. And gravity is on. Gravity can be turned off. And gravity is Earth gravity, 9.81 meters per second squared. Now I want to demonstrate some of the properties I added. Okay, so I select. And you do the same, please, once you create your rocket. It doesn't have to be exactly the way I did it. You can redesign or your rocket. You can make it much more simplified or more sophisticated. It's totally up to you. But move your cursor over the rocket and click on it with the left mouse button. That way your rocket is already selected. Now computer knows, okay, and it's ready to demonstrate to you its properties. So on the right-hand side, there is a command menu. Okay, the box on the right-hand side, the rectangular box, is the command menu. It's command menu. And the first tab is called Create tab. We already created everything. We have no business here. So I'm going to move on to the second tab, which is the Modify tab. You click on that. Okay? When you click on the Modify tab, it will demonstrate all the components of the rocket. Okay? Mass Effect's rigid body is already attached, so it is on the top. You can see that, and under the Mass Effect rigid body, there's the initial velocity. I assigned that initial velocity last class so that I tested, okay, if it's going to take it high enough. So when I clicked on that initial velocity, it's highlight the initial velocity. It will show me how much I set it up. I forgot. It's been several weeks. There's a winter break in between, so I believe it's 500 meters per square. But I forgot all about the total mass of the rocket. Also, I assigned it. So let's take a look at the rigid body. Is already should be set to dynamic, because we're going to make sure that the rigid body moves up in the air and based on the initial speed, and slow down, gradually slow down, slow down, slow down, and then at one point it's going to stop at certain elevation. We hoped that it will be 35 kilometers and then fall down after that. Okay. I set it up to use high velocity collisions, and I set it up collide with rigid bodies if there are any rigid bodies. The only rigid body other than the rocket is actually the floor, the ground. Physical materials, I did not change. This density is 1.0. The mass, I set it up to, let me see, there are quite a few zeros here. And let's count the numbers. 1, 2, 3, 4, 5, 6, 7, 8. Wow. This is more than 1,000,000 pounds. Okay, the eight zeros, and we're talking about 100 million pounds of load. And that's heavy. Okay, that's a very big amount. So that's about 50 tons, approximately the 50 tons. Okay, it's bigger than the Russian rocket recently launched into the space. Friction and static friction is set. The bounciness, there is a bounciness, and I'm just checking other features and the physical shapes, element 1 and 2 and 3 mirrors, and shape is custom shape, is we designed this. Okay, and there's nothing to change. Override the physical material. I'm looking for the forces, and forces are already, I did not change it. I'm going to the advanced, click on the advanced button, and velocity, that's what I'm looking for. I set up the speed to 500 meters per second. Initial speed is 500, and all of the initial speed is assigned to Z direction. Z is up, perpendicular direction, up in the sky. That is important for you to remember, to put the 500 meters per second square per second initial velocity. It eventually go down, gradually go down, okay, to the 0. So final velocity is going to be 0 when it reaches to the orbital elevation, and then it's going to fall down back to Earth, okay, increasing the velocity again, or instantaneous velocity, all the way back to 500 meters per second. So make sure that this velocity is entered twice, one for the Z direction and one for the speed, okay? And there is no initial speed here, okay? And I think everything, center of is use pivot. I think everything is set, and this information is maybe good enough only for my rocket. Your rocket may be different design, different weight, so you may want to modify this initial speed according to your needs of your rocket. Okay, that initial speed is important, and it is directly correlated to the mass of the rocket to reach and the elevation that you wish the rocket to reach to. Okay, there is a math, the engineering calculations, computations regarding to the initial speed, and in the classroom, please call me. I can explain that. Okay, there's a triangle of initial speed going down to 0 all the way at the top of the elevation, and then and we're gonna modify that in an actual flight plan. All right, so far so good. I give you all the information. Now, next step is going to be move your cursor over animation. On the top, on the middle, towards the middle to the left, there's an animation pull-down menu. Click on that. And now from there, you go to the mass effects. Click on the mass effects. Okay? When you move your cursor over the mass effects, there's rigid bodies, there's cloth underneath, constraints, and there's simulation. Move your cursor on the simulation, move on to the right, and play this simulation here. Click the play simulation. Now it's supposed to, your rocket is supposed to, I am rolling back, taken off, reaching up, gradually, steadily. And the green line in the background, you see the measuring tape that I created earlier. I create this measure tape for the length of 35,000 meters, so that you can see the improvement progress of the rocket. As the rocket progresses up in the air, it's also slowing down by the rate of the gravitational coefficient, 9.8 meters per second square per second. Every second, it's losing from 500 meters velocity per second velocity, 9.8. Less and less and less. Velocity is coming down. It's going to be zero at one point, and then rocket is going to stop and then start falling back. Now, my hope is it's going to reach to that maximum and the end of the measuring tape. Now, in the second try, I can modify the velocity, but I just want to see how well it will do. I will either increase or decrease the velocity. I can program it so that it reaches to a certain velocity. And this is the purpose of this particular video. In the next video, I will demonstrate how to create a video image of the rocket as it progresses up. And a video camera can be attached to the rocket in 3D Studio, 3ds Max. And there's a certain procedure that I want to demonstrate to you in the next video. At the bottom, there is a slide rule that demonstrates the number of the squares, number of the frames in the simulation. Right now it's 1600, 1700 frames, and I originally set it up to 3500 frames. Number of the frames per second is approximately 15 frames per second. So you can also calculate how many seconds it took for the rocket to ascend by just dividing that final number by 15. Okay, so now we're looking to the end of the rope and rocket reach to the elevation. Okay, our goal is achieved. At this point, I'm going to reduce the velocity, initial velocity, because it passed the elevation. So 500 was too much. Maybe I'm going to try 490. But it really slowed down. So I'm going to try something much smaller than 500 meters per second initial velocity, perhaps because it didn't have to pass the elevation we set it up. Well, thank you for your time, and please give it a try. And if you feel difficulty a few times, watch this movie. If you still have some difficulty, call me in the classroom, and I will help you. Thank you very much for your time.